Okay, guys, let's take a look at chapter 13. Chapter 13 starts in your book on page 267. In this chapter, we are taking a look at, as you can see by the title, the basics of intravenous fluid administration. So we're looking at IV bags. Most of us have seen how IV bags work. We know that it's a bag of fluid. Whatever that fluid contains may contain some type of medication, and that fluid drips out from the bottom at a particular rate into a patient through their veins. On page 267, you guys are looking at a couple abbreviations that you guys might see in this chapter. I only want to point this out simply because a lot of those abbreviations are just abbreviations and they don't really have much to do with the problem. You guys are probably familiar with things like hours and minutes. A couple things I will point out to you guys. GTTS is the abbreviation for drops. So that's something you guys will see as you're going through this chapter. Another thing like D5W down towards kind of closer to the bottom, kind of middle of that chart. D5W stands for 5% dextrose water. Things like that I'm pointing out to you guys. Simply because that's only the fluid that's in the bag. It has nothing to do with the problem or any type of calculation, so we don't have to do anything with the 5. It's just what's contained in the bag. It's the fluid. So just kind of word of caution as you guys are going through some of these problems today. Now, the great thing of this in this chapter is that this chapter, all the calculations we're going to perform in this chapter are formulas. Formulas that you guys all already have on your conversion charts that you guys were given in chapter 4. Now remember, these conversion charts, at this point, you guys can go ahead and start writing your notes on these. So as we go through things today, I may say, you may want to jot that down on your chart, because for next week's final, you guys are welcome to, like I said, have these covered in notes, anything that you may need. But on the formula side, on the back side of the conversion chart, you guys will see, is if you go halfway down that formulas section there, you'll see the percent formula, and then just underneath that you see to get GTTS/minute, that says drops per minute. And that's one of the formulas we're going to look at today. We're going to look at 4 different formulas, and all 4 of them are right there in order on your chart. It says to get GTTS/minute. The next one is to get milliliters per hour. The next one is to get time in hours. And then the last one we'll look at is to get the total volume. So the total amount of infusion. Those are the 4 we're going to look at today, and we'll see them as we go through our chart, or as our book, or through our book today. So the first one we're going to look at, those are the things that we're going to calculate with our IVs today. Again, they do drip. This IV will drip through this tube and into the patient's veins, and like I said before, at a particular rate. And these are things that we can calculate as we go through our chapter today. So the first one we're going to look at is that first formula on your chart, the GTTS, or drops. So if you need to make a note to yourself on your chart, you're welcome to change that to drops if you choose to do so. This formula is also on page 270 in your book, and the formula looks like this. Here's what we're going to be given to us in these particular problems. These problems say that what we're going to need to do, we're going to have to need to be given a volume. This particular volume, you'll notice on your on the formula in your chart, it says in parentheses, it says in milliliters. Now there's a reason for that. It says in milliliters because we know that volume can be measured in a number of different ways. In this case, we need that volume to be in milliliters. If it's not in milliliters, the only other thing you may see is liters. And so we're going to need to convert those liters to milliliters. And we know how to do that. We did that with our metrics last class, and we did that on our quiz that we took today. Whenever we have liters to get it to milliliters, that's 3 places to the right on our metric chart. So that would be, times 1,000 if you think about it. It's 3 places to the right to get it to milliliters. So it has to be in milliliters if it isn't already in milliliters. Then what we're going to do is we're going to divide that volume by our time. In this case, because we are calculating drops per minute, that time must be in minutes. We have to have that time in minutes. If it's not in minutes, we need to get it to minutes. And I'll tell you now, if it's not in minutes, it's going to be in hours. A lot of IVs are given over the course of a particular number of hours. So most of the time you're probably going to see these problems listed as hours. So to get hours to minutes, we have to think, well, how many minutes are in an hour? 60 minutes are in an hour. So if I had 2 hours, I know that that would be 120 minutes. 3 hours would be 180. 4 hours, and so on. We could see that what we're doing here is we're multiplying by 60. So if you need to on your chart, if you need to make a note to yourself, and maybe make a note that says, if in hours, simply just times 60. Something along those lines might make that a little bit easier. So we're going to take our volume in milliliters, divide it by our minutes, and then what we're going to do is we're going to take that and multiply it by a drop factor. And a drop factor is, you'll never have to convert your drop factor. Your drop factor is always going to be given to you as a drops per milliliter infusion rate. And that is something that's kind of set in stone based on the particular type of fluid that's in the IV, or the particular IV. So what's going to happen here is very similar to what we did in our dosage calculations. If we have a matching numerator-denominator in a formula, then they cancel out. So in this particular question, you'll see milliliters and milliliters, opposite numerator-denominator here. So what I'm left with in this problem is drops per minute when I calculate these out. So let's follow along with the formula here, and let's do a couple examples. Let's say we flip over to our practice problems. Down at the bottom of page 272, in practice 2, those are how the questions will be listed on your final exam. They will be word problems, and they'll be listed just like what you guys see down there. So in number 1, the problem reads that the physician has ordered D5W 1,500 milliliters in 12 hours using a 15 drops per milliliter infusion rate. So we need to figure out, well, what are they getting per minute? So again, we're following along that formula that's on your chart, and we need to make sure that they're in the appropriate units. So the volume that we were given is 1,500 milliliters. 1,500 milliliters. Again, that's the unit I need my volume to be in, so I don't have to do anything to it. It is correct. However, the time that they gave me was 12 hours. 12 is in hours. So I need, according to my formula on my chart, it says time needs to be in minutes. So what I'm going to have to do again, if we're given hours, I simply just multiply it by 60. And 12 times 60 gives me 720 minutes. So that's what I'm going to use in this formula because I need it to be in those minutes. And then my drop factor, like I said, is always given to me. This one, in number 1, they gave me a 15 drops per milliliter infusion rate. So I'm going to end up multiplying by 15. So in calculating this out, all I have to do is go ahead and divide. 1,500 divided by 720 gives me 2.08, but I take that and multiply it by 15, and it gives me 31.25. Everybody check to make sure you get the same thing. Typically, though, drops, because we can't regulate the size of a drop, most of the time drops are given in the nearest whole number because it's hard to regulate 0.25 of a drop. So this would be just rounded to 31. However, if you put 31.25 on the final, that would be totally fine. I'm not going to mark that wrong, so don't worry about that. But that's how we would calculate that out. And doing the same thing in number 2. Number 2 says the registered nurse is to infuse 1 unit of whole plasma. In parentheses, it tells me what that is in milliliters. 500 milliliters. Good. That's the unit that I need for my volume. I'm going to divide it by my time. My time is given over 4 hours. So 4 hours, again, not the unit I need it to be in. I want it to be in minutes. So I'm going to have to, in this case, take 4 times 60. 4 times 60 gives me 240 minutes. So that's what I'm going to use in my problem here for my drops per minute. And then I'm going to multiply it by our infusion rate, which is, in this case, 10 here on number 2. So I'm going to go ahead and take 500, now divide it by 200, let me clear that out here. I'm going to take my 500 milliliters divided by 240. That gives me about, no, that's not right. Sorry, calculator's being a turd today. Divided by 240 is also 2.08, and then I'm going to multiply that by 10, and I get 20.8, which you could round to about 21 drops per minute, or again, if you just take it, or say 20.8, that would be totally fine, but that's what we get on that one. So that's our drops per minute. We just need to make sure our units are in those appropriate units. And the benefit to having your chart in front of you during the final exam is our chart tells us what units we need. We need that volume to be in milliliters. We need to make sure the time is in minutes. And then the drop factor will be given to us. In the second formula we're using in this chapter is on the bottom of page 273, or if you're just following along in your chart, that's fine too. The next formula on the chart says that I'm looking for milliliters per hour. If I have a question that's asking me for the flow rate, and that milliliters per hour is also known as the flow rate, if you ever see that, and you can see that on your all's conversion chart there. Our flow rate is just that. Flow rate is milliliters per hour. Milliliters per hour. So to calculate that out, what I'm going to need is a volume. That volume needs to be in milliliters, and I'm just going to divide it by my time. In this case, because we're calculating milliliters per hour, those are the two units I need. I need milliliters and hours. As you can see, there are no units that are going to cancel out here because I don't have any identical units in numerator and denominator. I just have milliliters and hours, which is what I want in this particular problem anyway. I want it to just say those two units, milliliters per hour. So what we'll be given is that unit in milliliters. Again, if it's in anything else, if it's not in milliliters, it would be liters. And we remember convert liters to milliliters by moving 3 places to the right. As far as our time, most of the time our time is going to be given to us in hours. However, opposite of what we saw in the previous example, if for any reason our time is given in minutes, think it is the opposite of what we did in the previous example. In drops per minute, we needed our time to be in minutes. And so if it was given to us in hours, we multiplied by 60. So to get from hours to minutes, we multiply by 60. So if for any reason we need to get from minutes to hours, what do you guys think we're going to do? We're going to divide by 60. So if that happens to come up, you guys will see exactly how we calculate that out in our examples here. So take a look at some examples at the bottom of page 274, down in practice 3. We're taking a look at these flow rate questions. So number 1 in practice 3 down there at the bottom says 1 liter of D5WIV to infuse in 12 hours by an infusion pump. Again, in these questions, we only need 2 numbers. I need a volume, and I need to divide it by my time. My volume in this case was given as 1 liter. So just like our chart says, it does say that that needs to be in milliliters, just like previously. So because it's in liters, I need to get it to that milliliter unit. So that's on using our metric chart. On our metric chart, to get from liters to milliliters, we're going base to milli. So we're going to go 3 places to the right, and that would move our decimal 3 places to the right. So from 1, that would then make it 1,000. Okay, so 1,000 milliliters is what I'm going to use here. Again, 1 liter and 1,000 milliliters just happen to be the exact same thing. So I'm not changing anything. I'm just using it, in the correct unit that I need it to be in. So I'm going to use 1,000 milliliters here in number 1, and I need to infuse it in 12 hours. And again, because we are calculating the flow rate, which is milliliters per hour, that is the correct unit I need it to be in. So I don't need to change anything as far as the time goes. So I'm going to go ahead and divide that out. I'd have my milliliters as 1,000 divided by 12. That gives me 83.3. So this person would get about 83.3 milliliters each hour as they receive this particular IV. And milliliters, when you're given the flow rate, milliliters can be measured in decimals, so we can leave that as that decimal. No need to round that to the nearest whole number for any reason, so don't worry about doing that. So that's what we do in that particular question. Again, that's what milliliters per hour is showing us, is exactly how many milliliters they're going to get each hour if they need to receive this total volume. So the same thing is going to happen there in number 2. In number 2, the patient needs to receive 50 milliliters. It is in milliliters, so it's the unit I need it to be in. However, the time that was given was 30 minutes. In this particular case, for milliliters per hour, just as I mentioned before, I need that to be in hours, not minutes. So just exactly what I had said, previously as we started this formula, that to get my time from minutes to hours, that's the opposite of what we did on the last set of questions. To get from minutes to hours, I divide by 60. Some of you guys may even be thinking of that in your head. Well, 30 minutes, I know that is half an hour, so I'm going to use half or 0.5. You are correct. That is exactly what you'll use as far as hours go here. But another way we can get to that, if we think, well, 30 minutes, but divided by 60, 30 divided by 60 is 0.5. Yes, exactly, half an hour. So that's what I'm going to use here. So I'm going to use my 50 milliliters. I'm going to divide it by my 0.5 hours. And when I divide that out, 50 divided by 0.5 gives me 100, which makes complete sense. If they're getting 50 milliliters in a half an hour, that means they're going to get another 50 milliliters in the other half of that hour, giving them a total of 100 milliliters per full hour. And that's what we're trying to calculate, is what their flow rate is per hour, not per half hour. So that's what we'd end up doing in that particular problem. Just doing number 3, if you're looking through all the practice problems through there, number 3 actually is going to end up being very similar to number 2. You would end up taking 150 divided by 30. I mean, not 30 minutes. You'd end up dividing that also by 0.5, since that's half an hour. And then you get to ones like number 4. Number 4 says to infuse 1,800 milliliters. That's the correct unit I need it to be in. Over 24 hours. Also the correct unit I need it to be in. I need milliliters for my volume and hours for my time. So in this particular case, I don't have to change anything at all. So I just take 1,800 divided by 24, and that will give me 75, which means that patient will receive 75 milliliters per hour. So that's that formula. Moving on to the next formula. If you're following along in your chart, it's the very next one to calculate our time. And if you're looking in your book, it's on page 275. So our next formula is simply just the formula we just looked at with our flow rate. It's just rearranged. This time instead, we're going to be given the volume and the flow rate. So based on those two things, I should be able to figure out how long that's going to take. So they just took this formula and they rearranged it for us to calculate the time. So the time in hours, how many hours it's going to take. I need to take my total volume. Once again, that volume must be in milliliters. And this time I'm going to divide by the flow rate. And the flow rate will also be given to me in these problems. And I know my flow rate is my milliliters per hour. And you can see, guys, what's going to happen here. Milliliters and milliliters, opposite on numerator, denominator here, they're going to cancel out, leaving me with hours, which is what I want in this case, which is why that volume must be in milliliters. As far as flow rate, though, flow rate will always be given to us as milliliters per hour, so you don't have to worry about converting anything on that. So the example problems for our time formula, our time example ones are on the bottom of page 276. So on page 276, we get down to practice 4. And I'm going to go take a look at number 1 first. Number 1 says, the nurse receives an order that reads 500 milliliters of D5W. Again, remember D5W is simply just what's in that IV bag. Of D5W IV at 50 milliliters per hour. So if we think about that and what's happening in this problem, this person needs to receive a total of 500 milliliters. They're getting that at a rate of 50 milliliters per hour. So they're getting 50 milliliters in the first hour. They're going to get another 50 milliliters in the second hour, giving them a total of 100. Then they're going to get another 50 in the third hour, giving them a total of 150. Then another 50 in the next hour. So you can see what's happening here. They're getting 50 milliliters at each particular hour, so we should be able to figure out how many hours that's going to take. And I could sit there and tally that up if I wanted to, but a much quicker way would be to follow our formula, which says to take our total volume. Our total volume was 500 milliliters. It is the unit I need it to be in, so I don't have to do any converting. And I'm going to divide by my flow rate, which was 50. So if I take 500 and divide it by 50, that gives me 10, which means it's going to take a total of 10 hours for me to finally reach that total volume of 500. And that's all I have to do on those. So just to do a couple more examples to make sure we feel pretty good with that. Number 2 says a baby is to receive 300 milliliters at 25 milliliters per hour. So again, there's our total volume, 300 milliliters at a rate of 25 milliliters per hour. So I'm going to go ahead and divide that out. Sorry, my handwriting is terrible. 300 divided by 25, that would take 12 hours. Just take that and then divide that out. I want to point out to you one like number 4. I think it's number 4. Yes. One like number 4. Same exact thing that we're looking at here, that I need to calculate my time. So if I'm given a total volume, my total volume in number 4 says that they need to receive 1,000 milliliters. It's in the correct unit I need it to be in, so I don't have to do anything to it. And I need to infuse at a rate of 140 milliliters per hour. 140 milliliters per hour. So in dividing this out, the reason why I wanted to show you guys this is because 1,000 divided by 140 is 7.14. Correct answer. That's what I'm looking for on the final. You can give me that answer in decimals. Some of you guys, though, may be thinking, well, what is 7.14 in terms of time? Because time is measured in hours and minutes, not decimals. That being said, like I said, 7.14 is absolutely an acceptable answer. That's all you guys have to do for me on the final exam. But just for those that are curious, that does not mean 7 hours and 14 minutes. What it actually means, because of the difference between decimals and time, remember decimals, if we were just, again, this is just for those of you guys that are curious. You do not have to do this on your final exam. Let me get this out of the way real quick, and I can show you what I mean. 7.14 as a decimal, this is the same thing. If I were to think about it just real quickly, 7 is my amount of hours. It is 7 hours. But looking at just the 0.14, so let me erase that 7 real quick. Looking at just the 0.14, that's the same thing as the fraction 14 over 100. If we go back real quickly to chapter 6, converting decimals to fractions, that's what that would give me. However, time is not measured out of 100. Time is measured, again, how many minutes are in an hour? 60. So one way that we could double check this, if you wanted to give me your answer in hours and minutes, well, since 14 is, or 0.14 is the same thing as 14 out of 100, but I want to know, well, then what is that out of 60? You very well could set that up as a proportion, which we are very, very, very familiar with because of all the practice that we've had with proportions. And you could go ahead and calculate this out as 14 times 60, which gives you 840, and then dividing that by 100 would give you 8.14. I'm sorry, not 8.14, I'm sorry, 8.4, which means that 7.14 measured in time is actually closer to about 7 hours and 8 minutes, if that makes sense. Like I said, though, that was just for the sheer fact of showing you guys who may have been curious as to what 7.14 meant in terms of time. But 7.14 is totally an acceptable answer on the final exam. You don't have to worry about giving me that answer in hours and minutes. No worries at all. Okay, last formula is taking that same exact formula and just rearranging it to where this time, if I'm told, okay, what is the patient going to take per hour? So I'm given the flow rate, milliliters per hour, and I'm also given the amount of time I want to give that infusion. From that information, I should be able to take that and calculate that out to see what they're going to receive total after the amount of time that they need to receive that IV. So the formula that you're looking at on this, the next one to find the total volume is just the very next one on your chart, which says to find the total amount of infusion, or on page 277 for those that are following along in your book. And that formula says this: to calculate the volume, what I'm going to need is the time. And again, the time will be in hours. You don't have to worry too much about converting here. Chances are it's already going to be given in hours. And I'm going to multiply it by that flow rate. And again, the flow rate is milliliters per hour. So what's going to end up happening here is the unit hours are the same here, and they're canceling out, leaving me with the unit milliliters. So that will be my total volume in these problems. So let's take a look at some examples to find our total volume. And these are over on page 278. We're looking over on page 278. I'm going to look at number 1 there in practice 5. Number 1 says this. Number 1 says what's ordered is D5 1/2 NSIV. Sounds kind of crazy to have all that in that IV bag. But again, no need to worry about what's in the bag. That simply just means 5% dextrose, 1/2 normal saline IV. Again, nothing about that is in the problem. I know a lot of people, when they see that problem, they think, oh my gosh, a fraction. And no worries. No need to worry about any fractions here. I'm only looking for the flow rate and the time because I want to multiply those two. So this says to order D5 1/2 NSIV at 125 milliliters per hour for 12 hours. So to calculate the total volume, I just simply need to take those two things, my flow rate, 125 milliliters per hour, and that's going to be given over 12 hours. So just by multiplying those, we can calculate 125 times 12. That's going to be about a total of 1,500 milliliters. Because that's what's happening. They're receiving 125 milliliters this hour. They're going to receive 125 milliliters the next hour. They're going to receive it again the next hour, and they're going to do that a total of 12 times, according to the problem. So that's why we ended up just multiplying those two in order to get that total volume. Okay, same thing down in number 2. Number 2 says what's ordered is a penicillin IV over 4 hours at a rate of 75 milliliters per hour. So again, I'm taking that total volume, 4 hours, I'm sorry, not the total volume, the time, 4 hours, multiplying it by the flow rate of 75 milliliters per hour. And when I take those two and multiply those two together, I should get 300. Yes, I should get 300. So that person's going to receive a total of 300 milliliters. And that's our last formula for chapter 13. There are plenty of practice problems in there, so feel free to practice some and let me know if you guys run into any questions as you do so. To make it easier for you guys on the final exam, you guys will see all of those questions in order. You'll see 2 of each particular formula all in the same order, so all you need to do is just go down your chart. So you'll see 2 questions about drops per minute. The next 2 will be a question about milliliters per hour. The next 2 will be about time, and then the next 2 will ask for the total volume. So although they're pretty easy to figure out because the question will ask for the particular either volume or time, so they're pretty easy to figure out anyway, but I just wanted to make it as less confusing as possible, so you'll see those all in that exact same order. So I hope that makes it a little bit easier. All right, guys, you all let me know if you have questions as you all practice some of those practice problems. Thanks.